Good day everyone. Today Group 8 will be presenting on the fascinating transition metal zinc. Firstly, let's explore its natural occurrence and the minerals in which it can be found. Zinc is an essential trace element that plays a vital role in various biological processes, and understanding its natural sources is crucial for both industrial applications and health sciences. Let's begin with where zinc can be found in nature. Zinc is the 24th most abundant element in the Earth's crust. It is not found in its pure metallic form in nature due to its high reactivity. Instead, it is typically found in minerals and ores. Zinc occurs primarily in the form of zinc sulfide minerals. There are some main minerals that are source of zinc. First is cephalerite, also known as zinc blende, the most important ore of zinc. It typically contains about 67% of zinc. It can range in color from yellow, brown to black due to the presence of iron impurities. Next, smithsonite or zinc carbonate. It often forms through the weathering of cephalerite and is commonly found in the oxidized zone of zinc deposit. It has a characteristic of greenish blue to blue color and is often found in globular form. Moving on, zincite is a rare zinc oxide mineral. It is typically deep red or orange in color due to the presence of manganese. Lastly is hermimorphite is a zinc silicate mineral.
The chemical properties for zinc: first, it will react rapidly with the air and then forming a dull gray zinc oxide coating. And then it also will react with the halogens, oxygen, alkalis, acids, ammonia, and more or less active metals compared to zinc metal. And then for the aphorism, it will react with the both acid and alkalis. And then last but not least, it will form a complex compound known as hydrazole zincates when reacting with the alkalis. So for the physical properties, for the appearance, zinc is silver gray, and then the density is about 7.13 gram per centimeter cube, and then the color is like bluish white like that, and then we have melting point around 420, and then for the elasticity and the malleability, it will increases when heated to approximately like 100, and then for the boiling point is about 906, and then for at the temperature above 200 degrees Celsius, it will lose its elasticity and becomes a gray powder. And then the heat capacity and heat conductivity is high. And last but not least, the conductivity is a good electrical conductor.
I'm Nurul Alisha, and now let's begin to the application of zinc. It is used in automotive. Zinc alloys are often used as coating for galvanized steel. Galvanizing steel parts and components in a vehicle helps to prevent corrosion. Zinc also can be used in zinc-ion batteries and electrolyte. It is safer, cheaper, and longer lasting than lithium battery. The raw materials used are excessively more abundant than those used for lithium-ion battery. As for electrolyte, zinc uses a water-based chemistry that results in a much safer environment as it is unable to sustain fire. Zinc alloys are used throughout the construction industry in a wide range of product and application. It can be used as solder, household fitting, and as a coating on roofing. Zinc can be combined with other metals to create alloys such as brass, a popular alloy of zinc and copper, used in various applications such as musical instrument, decorative item, and plumbing fixture. Zinc is essential for plant growth. It is a component of fertilizer and help prevent zinc deficiency in crops. Plant require zinc for proper enzyme function and overall health. Zinc can also be used as pigment in plastic, cosmetic, photocopier paper, wallpaper, and printing inks. So now let's go to environmental consideration of zinc. Zinc have some disadvantages and also advantages. For disadvantages, there are some unwanted byproducts from zinc production that include sodium oxide that is corrosive and violent when exposed to water, and also carbon monoxide, which is toxic to humans and animals as well as ozone forming. Next, industrial sources or toxic waste site may cause the zinc amounts in drinking water to reach levels that can cause health problems. Some fish can accumulate zinc in their body when they live in zinc-contaminated waterways. When zinc enters the bodies of these fish, it is able to biomagnify up the food chain that can cause health problems to living things such as human, animals, and also plants. Water-soluble zinc that is located in soil can contaminate groundwater. For the advantages, it is completely recyclable. This means that it can be produced easily and effectively from all material taken from demolished or re-roofed structure.
Let's move on to how zinc is extracted from its ore using the pyrometallurgy method. Pyrometallurgy is a process that involves high-temperature techniques to extract and purify metal. It is one of the primary methods used for extracting zinc from its ore. Pyrometallurgy involves a series of steps including concentration, roasting, reductions, and refining to extract zinc from its ore. The main ore used in this process is cephalerite, zinc sulfide. Concentration is where zinc ore is crushed and concentrated using froth flotation method. Next step involves roasting, where zinc sulfide ore is heated in the presence of oxygen and converted to zinc oxide and sulfur dioxide. The sulfur dioxide gas is collected and often used to produce sulfuric acid as a valuable byproduct. In reduction step, zinc oxide is reduced to zinc metal using a reducing agent such as carbon in the form of coke. The reaction takes place in the blast furnace at temperatures around 1400 degrees Celsius. Zinc vapor is produced and needs to be condensed. Lastly, the refining process often involves fractional distillation or electrolysis. Fractional distillation separates zinc from other metals based on their boiling points, while electrolysis further purifies the zinc.
In the process of hydrometallurgy of zinc extraction via electrolysis, the journey begins with the crushing and grinding of zinc ore into a fine powder, followed by leaching with a sulfuric acid solution. This leaching action dissolves the zinc sulfide, forming a zinc sulfate solution while leaving behind the unwanted gangue material. Next comes purification to remove impurities like iron and cadmium, crucial for the efficiency of the electrolysis process. Finally, electrolysis takes place, where the purified zinc sulfate solution is subjected to an electric current. This prompts zinc ions to be deposited onto aluminum cathodes as zinc metal, while oxygen gas evolves at lead-silver anodes. The zinc metal is then stripped from the cathode, melted, and cast into ingots. Through this meticulous process, zinc is extracted and refined, ready for use in various industrial applications. Hope you enjoyed the insightful video presentation about zinc from Group 8. Thank you for the time you have taken to watch our video, Doctor, and have a nice day.